This peculiar cup could give astronauts the espresso experience in space. The ISS is about to get its very own espresso machine, designed to provide hot, fresh, delicious coffee in a microgravity environment. We're sure it's going to be a delight to the astronauts surviving on whatever freeze-dried excuse for coffee they have up there. There's just one thing: the ISSpresso, designed by Italian company Argotec, serves its coffee in a pouch, from which the astronauts are to sip with a straw. Sure, it's a coffee delivery system that does the job, but it's not quite the same as drinking espresso from a fancy little cup. The rather odd drinking vessel pictured above aims to solve that problem. Designed by a team consisting of Mark Weislogel, a professor in the Thermal and Fluid Sciences group at Portland State University who has spent quite some time pondering the problem of drinking coffee in space, his colleague researcher Drew Wilmer, and high school student Nathan Ott. The coffee cup is designed to give astronauts the feeling of drinking from a cup. Because the variety of espresso drinks is extensive, we made specific property measurements to assess the effects of wetting and surface tension for Italian espresso, cafe latte and cafe americano, Weislogel said. For some people, the texture and aromatics of the crema play a critical role in the overall espresso experience. We show that in low-gravity environments this may not be possible, but suggest alternatives for enjoying espresso aboard spacecraft. To replace gravity, the cup's odd shape is designed to contain the liquid coffee using surface tension. The shape of the container can passively migrate fluid to desired locations without moving parts using passive forces of wetting and surface tension, Weislogel said. Its geometry is the smart part, which operate the fluids control system without requiring pumps or centrifugal forces. The cup wouldn't necessarily work well with any liquid. Coffee has a relatively high proportion of oil from the beans, which means it has a higher viscosity and stronger surface tension, if only by a little. In this case, a little is enough. The cup has been tested using 3D printing to manufacture the cup, something the astronauts aboard the ISS could now try doing themselves, and rapid drop tower tests to make sure that the cup can adequately hold the liquid inside under simulated microgravity. And the design has implications beyond a simple cup of joe. We're striving to use our new methods to reassess all fluid systems aboard spacecraft, including cooling systems, fuel tanks, water processing equipment for life support, plant and animal habitats, medical fluids, foods, etc., Weislogel said.